Welcome to Trends and Technologies for Managing Plant Operations and Assets, this session. I'm going to other way? There we go. Yeah, okay, thanks. There's a lot of emerging technologies, or I should say some significant emerging technologies out there that can enable and direct is directed right at plant lifecycle management, to plant design and infrastructure, and there's a list of things here. This is a little bit part of what we were talking about last year, and a few other things that are more specific to the asset lifecycle management and plant design and infrastructure area. The big data analytics, cloud mobility, all those things, laser scanning and GIS technology. Today, what I would like to focus on are two areas. I'd like to focus on asset lifecycle management in the context of the Internet of Things, which is one of the primary themes of the forum overall this year. And also the other area that is really, I think, the main focus of this session is the virtual environment, the 3D virtual environment, and how it's really enabling the ability for designers in plant design and infrastructure and AEC to really build a virtual environment that validates the physical environment and the physical facilities that they're designing and building. So let me start with the asset lifecycle management and the Internet of Things. Today's assets come in many flavors, many shapes, many sizes. They're all complex. They all represent very expensive and sometimes long-lived projects. There's a range is really broad, and they all involve a significant initial capital expenditure. That's what they really have in common. But the real common thread among all these highly engineered assets is the need to operate and maintain them for decades safely and profitably. So the first thing I'm going to talk about here is before I get into the virtual environment, is the Internet of Things as it extends to the asset lifecycle. It's really about breaking it down into two significant areas. It encompasses connectivity, connected devices, connected assets, connected sensors, whatever it takes to actually connect the equipment and the facility and the asset. And then the other element of it that's quite important is the intelligence that it's going to take to enable these assets to proactively provide data and information. What we probably really want to get to is a state of awareness, of self-healing, if you want to really stretch this out in those terms. Industrial companies, plant design, facilities and plants and so forth they can use information from these connected devices to basically the idea is to lower costs and enable the maintenance and so forth, to optimize the processes, create kind of transformative new applications and services and even new business models. The IoT architecture that we're really dealing with today really builds on a lot of current in emerging technologies, and it also builds on a lot of what's really connected out there in industry already. There's many in the automation space will tell you, well, what are you talking about connected factories, connected facilities, connected plants for? Because we have a lot of connectivity already, and that's very, very true. I think that my point here is this is going towards an era of intelligence at the asset to already leverage the connectivity that we have. So what are the components? What are the IoT components for asset management? Well, as I talked about, it's embedded assets. It's intelligent assets. It's equipment and assets embedded with sensors and processors and memory, and obviously communications. It's software-defined behavior for the asset. It's reactive and predictive and even social in terms of the dissemination of the information. It's the notion is to generate more usable data, more actionable data. And as I just mentioned, it could potentially be we're really looking toward getting to a state of potential self-awareness and autonomy. And of course, as I said, current technologies are going to support this to some extent. Big data, what do you do with it after you get the data, after you capture the data? Well, you have to analyze it. That's a really, really important part of it. So analyzing the big data after you capture it and so forth is going to be all a part of the process. So it's all about the analytics. It's about the descriptive, predictive, and prescriptive analytics that go along with this. It's intelligent information and so forth. And it's people. We're going to connect. Part of this whole thing that is not just connecting devices, but it's connecting people at the same time, so there can be interaction. The industrial Internet of Things, it enables new asset systems and new operational optimization. So it's going to involve plant and infrastructure operations. It's going to involve enterprise asset management, or EAM. Of course, obviously, as I just mentioned, it's going to involve analytics and applications, but also an important aspect of it is going to be the intelligent asset itself and the connected value chain. So, with that sort of preface, I guess, if you will, about IoT and ALM, I want to really jump into, the 3D virtual environment for plant and infrastructure. So today, across the design build, what we're really moving to, or what we have moved to, is this: we've gone from design, build, and operate, or design, build, operate, and maintain, to add another word in there: design, build, simulate, operate, and maintain. The 3D plant design software providers are offering some amazing things right now. Next generation 3D simulation tools that really enable the designers and operations, and I'll get to that in a second here, to create this immersive virtual reality simulation environment. And it has a lot of really practical uses. The engineers and the developers using these systems can model and design the plant and the facility the same way they always have, but now there's tools available that once they develop the 3D models, they can be rendered into as components of this entire immersive 3D virtual environment. This is rendered is the key word here, because the rendering on this is really quite good. It's really amazing, and it not just pumps and particular equipment and everything, but the entire plant and everything within it. The concept of the virtual plant involves an integration of the entire process of plant design, in operation, from mechanical, electrical design to everything that enables and actually is a functional is a part of the the functional facility, the functional plant. Designing a virtual plant brings together these multiple design disciplines and the integration of the mechanical disciplines, electrical designs, the layouts of the piping and PIDs and all that, and the building systems engineering itself. So I'm really talking about a very wide, encompassing a wide area here. Virtual simulation for power, process, utilities, energy, and AEC. Really, actually, the notion of this is let's validate let's build a virtual representation of the physical world so we can validate what we're designing and what we're going to maintain and operate. These environments today can be created for entire plants, refineries, drilling platforms, nuclear reactors and facilities, power gens facilities, in any kind of large-scale construction site. You've probably already seen lots of examples of this already. So it's both micro and macro and level. You can distill it down to individual troubleshooting at a valve or something that's leaking all the way to the entire plant itself, the entire facility. It really benefits all domains of the plant life cycle and the operational assets. It's design, build, discovery for advanced infrastructure. It's safeguarding your critical assets. It's an end-to-end security with optimal situational awareness. It's building an environment, and this is something that I should point out. We can build a virtual environment so that we can run operational scenarios, safety scenarios, this is quite important, and run maintenance scenarios and operational maintenance simulations involving the avatars of the workers themselves moving around and doing the work. What we're finding is that, yes, that is right now at this juncture, the operations and maintenance people like this a lot. If I was talking to Chevron not long ago, and they were saying that it would be what's going to be really, really important for them when they're building and designing their offshore platforms is that in the past they have to wait till the entire platform is completely built and basically operational before they can take the crews out for training and so forth, and that just isn't going to fit in the whole going forward in terms of. One of the topics that was brought up early on in this forum was the expense of the projects. This is going to enable them to completely validate and train operationally and from a maintenance perspective and from safety perspectives before the crews ever are out there on the physical platform, and that's going to be just totally critical for these companies. The other aspect of this is, and it's interesting enough, and this is probably going to come down the road later, is these simulated environments are going to enable better design because, and when the actual construction starts, when you go from the design phase into the construction phase and the erection phase and so forth, the EPCs and the construction contractors and all the rest of the EPs that are involved in the overall life cycle are going to be able to simulate movements and installations with cranes, and we're seeing the implementation of physics-based simulation where they can actually determine forces and weights and all kinds of things in the construction phase, so that they can actually use this while they're in the construction phase. So this is where this is really going. Laser scanning, point cloud applications. Obviously, they've been out there for a while. They're really adding a lot of value to this entire process. You overlay the point cloud model over the actual design model. You can actually see differences and variations and so forth, and this helps immensely in not only in brownfield, but it can also be applied to greenfield quite well. Of course, as I mentioned just earlier, these the 3D design models can be used to create these very photorealistic renderings of plant and equipment, and it's only going to get better and better as we go, as we go on. So the value proposition for this, I think it's pretty obvious, and it's probably pretty obvious to a lot of the folks in the business. But these virtual environments, as I said, can be created to simulate entire facilities, field operations, maintenance, trainings, and safety. They replace. It's not that they really have physical prototypes and so forth, but they're providing, as I just mentioned, an environment where they can simulate while they construct, and so forth. They can, and of course, this is a big hitter. It can significantly shorten the project duration. Of course, that's directly involved with cost, ultimately, and then of course the real-time simulation for training, operations, and support can be used across all industries in this space. Okay. One quick thing before I wrap up here, I want to kind of touch on this integration of what I call asset lifecycle management and PLM, or product lifecycle management, because it's really two completely separate domains. I think, and from my perspective and the research and so forth that's been going on for some time that I've been doing, I'm starting to see this kind of come together. Now, this represents two completely different sets of companies and technologies and applications, but I see this coming together from the perspective of equipment that goes in the facility. So all that equipment out there in the production process and so forth is all the equipment is usually designed as some kind of a PLM application for the most part, and those systems need access. The owner operators need access to that information. And of course, then we have the plant design or the plant life cycle of design, build, operate, and maintain, and which represents the facilities, the plant, the factory, the infrastructure, and so forth. And so what we're seeing emerge here, and this is coming out I think in different ways and different offerings from the industry itself, from the suppliers of this, is this kind of common interoperable platform for ALM and PLM. It's going back to this notion. There's been a lot of lip service given to single source, single repository, single source of the truth, all these kinds of things. I think it's actually coming together in different ways. We're not quite there yet, but that's just something I see actually happening. So the future trends, we're going to see the continued 3D virtualization. We're going to see this merging of virtual production, simulation, digital manufacturing with plant and infrastructure virtual environment simulation. We're already seeing that with certain partnerships between infrastructure and plant design folks and PLM folks. Virtualization of the plant processes will kind of ultimately enable safer operations and enhanced operator training. We've talked all about that already. Basically building these 3D virtual environments will drive the optimization back to the design itself, to the plant design, to the original design itself. You go out there, you build it, you model it, you design it, you simulate it, and then after you simulate it, you go back and say, maybe we should reconsider these design aspects. And then lastly, this virtual 3D plant infrastructure environment it'll enable this validation of the whole connected and intelligent asset, this thing that I've been talking about here. The physical world will be validated by the virtual world.